Welcome to my channel, 6th class mathematics, chapter 8 geometry. Today I will explain about triangles. Triangle is a simple three-sided figure. For example, ABC is a triangle. It is a closed figure. Here AB, BC and CA are called the sides of the triangle, and this angle A, angle B and angle C are called the angles of the triangle. Angle A is written as angle BAC and angle B is angle ABC and angle C is angle BCA to be accurate. These are called the angles of the triangle, and the points A, B and C are called the vertices of the triangle. So a triangle is a simple three-sided closed figure. It has three sides, three angles and three vertices. So depending upon the measurements of the sides of a triangle, they are classified as scalene triangle, equilateral triangle, and isosceles. So, a scalene triangle, a triangle in which no two sides are equal, is called a scalene triangle. The two sides are different. The three sides of the triangle are different. That is, the length AB is not equal to BC, or BC is not equal to CA, or CA is not equal to AB. Like that, no two sides are equal in a triangle. Then the triangle is called a scalene triangle. This is a scalene triangle. Next, equilateral triangle. If all the three sides are equal in a triangle, it is called an equilateral triangle. For example, A, B, C. Let the three sides are equal. Let it be 3 centimeters and 3 centimeters and 3 centimeters. Then the three angles are also equal. Each is equal to 60 degrees. Such a triangle is called an equilateral triangle. So equilateral triangle is a triangle in which all the three sides are equal. As the three sides are equal, the three angles are also equal. So this is an equilateral triangle. Next, isosceles triangle. A triangle in which only two sides are equal and the third side is different is called an isosceles triangle. A triangle in which two sides are equal is called an isosceles triangle. For example, A, B, C. These two sides are equal. That is, AB is equal to AC and BC is different. Then this triangle. Next, based on the angles of a triangle, triangles are classified as acute angled triangle, right angled triangle and obtuse angled triangle. Acute angled triangle means all the three angles of a triangle are acute, that is less than 90 degrees. For example, triangle ABC, let us take the triangle ABC and let the angles be 40, 60 and 80. And here the angles, all the three angles are acute, less than 90 degrees. Therefore, this is called an acute angled triangle. Next, right angled triangle. If one of the three angles of a triangle is right angle, that is 90 degrees, then that triangle is called a right angled triangle. For example, this is the right angle. Right angle is denoted like this. So we need not write 90 degrees again. If we put like this, it is 90 degrees. So triangle ABC is a right angled triangle, and the angle at B is 90 degrees, right angle. Next, obtuse angle triangle. If one of the angles in a triangle is obtuse, that is greater than 90 degrees and less than 180 degrees, or if an angle lies between 90 and 180 degrees, it is called an obtuse angle. If one of the angles in a triangle is obtuse, then the triangle is called an obtuse angle triangle. For example, here this is greater than 90 degrees, let it be 110 degrees, and this may be 40 degrees, and this may be 30 degrees. So triangle ABC is an obtuse angle triangle. Here the angle A is obtuse angle and the other two are obtuse angles. Therefore this triangle is called obtuse angle triangle. Therefore, depending upon the angles of a triangle, triangles are classified as acute angle triangle, right angled triangle, obtuse angled triangle. Next, isosceles right angled triangle. If in a triangle two sides are equal and one angle is right angle, then the triangle is called isosceles right angled triangle. For example, if we take this angle, triangle PQR, here the angle at Q is right angle and these two sides are equal, then triangle PQR is called an isosceles right angled triangle. So triangle, this is read as triangle PQR. So PQR, triangle PQR written like this symbolically, and this is the right angle. Therefore this triangle has a right angle and two sides are equal. Therefore this is an isosceles right angled triangle. So here the angles opposite to the equal sides are also equal. These two angles are equal. Angles opposite to the equal sides are equal if it is x, and this is also equal to x, and this is the right angle. Next, let us note some important points. A scalene triangle may be an acute angle triangle, right angle triangle, or obtuse angled triangle. So for example, all the three angles are acute. So triangle ABC is an acute angle triangle and these three sides are different. It is a scalene triangle. As the three sides are different, it is a scalene triangle, and the three angles are also acute. It is an acute angle triangle. So a scalene triangle may be acute angled triangle and also the right angled triangle. So here it is a PQABC. It is a right angled triangle, but the three sides are different. Therefore it is a scalene as well as right angle. So a scalene triangle may be acute angle triangle or acute angle triangle, and obtuse angle, it may be obtuse angle triangle. This is an obtuse angle triangle. This is the angle greater than 90 degrees and the obtuse angle, let it be 110 degrees. And this may be 30 degrees and it is 40 degrees. So this angle PQR is an obtuse angle triangle and these three sides are different. Therefore it is a scalene. Therefore scalene triangles may be acute angle triangle, right angle triangle, or obtuse angle triangle. Next, an isosceles triangle may be acute angled triangle, right angle triangle, or obtuse angle triangle. For example, ABC and triangle ABC in isosceles triangle, because these two sides are equal and this is different. It is greater than the two sides. So it is an isosceles. But all the three angles are acute. So it is isosceles and also acute angle triangle. So an isosceles triangle may be an acute angle triangle. And if we take a right angle such that two sides are equal, let it be A, B, C. These two sides are equal and it is a right angle. This is different. This is right angle triangle as well as isosceles. Therefore, an isosceles triangle may be right angled triangle. And also an obtuse angled triangle. These two sides are equal. And this angle is obtuse, greater than 90 degrees. And these two sides are equal. Therefore, it is an isosceles triangle as well as obtuse angled triangle. Therefore, an isosceles triangle may be acute angle triangle, right angle triangle, or obtuse angled triangle. Next, equilateral triangle. Equilateral triangle cannot be a right angled triangle because as the three sides are equal and the three angles are also equal to 60 degrees, three sides are equal. Let it be ABC. So an equilateral triangle means a triangle whose three sides are equal. Therefore, it is always acute, whose angles are equal to 60 degrees each. So an equilateral triangle cannot be a right angle triangle or obtuse angle triangle. It is always an acute angle triangle and the angles are also equal to 60 degrees each. Next, we will see some statements of the properties of a triangle. So sum of the three angles of a triangle is equal to 180 degrees. That is sum of the three angles of a triangle is 180 degrees. And sum of any two interior angles of a triangle is equal to the exterior angle. That means here let us take a triangle ABC. So these angles are called the interior angles. And if we extend a side BC, the angle made by this extended side and the other side and is called the exterior angle. Exterior angle. So sum of two interior angles. Let us take the values of the angles be A or capital A. Let us take the angles also capital A, B and C. Sum of the two angles, interior angles. Sum of any two interior angles is equal to the exterior angle of the third angle, third side. So sum of these two interior angles is equal to exterior angle at this vertex, third angle. So this angle, exterior angle is read as, let us take a point D on this side, angle DCA. Angle DCA. So sum of any two interior angles is equal to exterior angle at the third angle. So sum of any two interior angles is equal to the exterior angle. At the other angle, at the third angle or vertex. Next, third point. Next, third point. The sum of any two sides of a triangle is greater than the third side of that triangle. For example, if we take a side A, B, for example, if we take a triangle ABC, let the sides of this triangle be A. the side opposite to capital A, vertex A is A. Let the side opposite to vertex B is B. Let the side opposite to vertex C is small c. Next, sum of any two sides. Let us take these two sides, A plus C, is greater than the third side. So, sum of any two sides of a triangle is greater than the third side. If we take A and B, sum of A and B is greater than the third side, is greater than the third side C. Or B and C, if we take sides B and C, B plus C is greater than A. Thus, sum of any two sides of a triangle is greater than the third side. Next, fourth point, the difference between any two sides of a triangle is less than the third side. The difference between any two sides of a triangle. Let us take a triangle, let it be A, B, C. So, the sides A, this is B and this is C. So, small a represents the side opposite to the vertex capital A. B represents the side opposite to the vertex capital B. And small c represents the side opposite to the vertex capital C. So, the difference between any two sides, A difference C, or A minus C, or C minus A, whichever is greater, the smaller one is subtracted from the greater one. So, A difference C is less than B. So, the difference any two sides is less than the third side. If we take these two sides, the difference between A and B is less than C. Similarly, the difference between B and C is less than A. So, sum of the two sides is greater than the third side and the difference of any two sides is less than the third side. The angles opposite to equal sides are equal. The angles opposite to equal sides. Let us take a triangle in which two sides are equal. Then the angles opposite these two sides, that is opposite to this side is this angle and opposite to this side is this angle. So, suppose this is a triangle ABC and this side is B and this side is C and this side is A. As B and C are equal, the angles B and C are equal. So, the angles opposite to equal sides are equal and vice versa. Angles opposite to equal sides are equal and sides opposite to equal angles are equal. If the angles in a triangle are in increasing order or decreasing order, then the sides opposite to that angle are also in the same order. Let us take a triangle ABC in which the angles are 50, 60 and 70. That is, angle B is less than angle C is less than angle A. So, these are increasing order. Angles B, C and A are in increasing order. Then the sides opposite to them, that is the side opposite them B, this is C and this is A. And these are also in the same order. B is less than, C is less than A. The sides opposite them are also in the same order. Similarly, vice versa. If the sides are in increasing order or decreasing order, the angles opposite to them are in the same order. So, these are some of the properties of angles.